I wanted to cover a couple of questions regarding the quiz for Chapter 2. And a couple of them that I wanted to talk about was looking at 9 and 10. And some of these were still incorrect in the rewrites with your groups. So if we're looking at drawing out a conjugate base, that means that these have lost a hydrogen. So we have two hydrogens kind of shown here, and we're going to have two different compounds. So these aren't chemically reacting with each other. We're just dropping off this proton. So I'm going to draw the left structure. I'm going to start 1, 2, 3, 4, 5 attached to an oxygen, double bonded attached to an oxygen. What has happened is we've lost that proton and the electrons were given to that oxygen. So we should have a negatively charged oxygen on that group because the proton left, not it, but it left the electrons with it. The other compound here with the nitrogen, we draw out 1 carbon, 2, it's attached to a nitrogen, that's attached to another carbon, and the electrons here have left that bond, and we're going to then just have an extra lone pair. So there's already a lone pair over here. If we draw out the lone pairs of all these atoms here, then we can see that it had a lone pair, so it's going to get another set of lone pairs. So if we do the formal charge calculation, we can look at now nitrogen has 1, 2, 3, 4, 5, 6 of its own electrons. That's one more than normal, so it will also have a negative charge. So that's the conjugate base. If we're looking at the conjugate acid, that means what we're doing is the opposite. We're actually going to add a proton here somewhere. So in order to do that, we need to know where the lone pairs are or where the double bonds are, because those are the elements that are going to be grabbing protons. So protons are floating around. How does it grab those? It's going to get them through interacting some of these lone pairs with the element. So you could have used any of these lone pairs and drawn out that new structure, and I would have given you credit for it. But here we're going to have oxygen. Now we have an extra bond, and that is going to now have a positive charge. Whatever thing attaches to it is going to get that positive charge. And here we have the nitrogen. If we have a hydrogen already down here, and now use that lone pair, we're going to have a positive charge on it. So those formal charges have to be recognized when we bond to or use those lone pair of electrons to bond to something else, that we're going to change the charge state of that bond. The next problem some people had some issues with was problem number 11, and it was really this second step. So when I look at numbering these oxygen, I'm going to number this 1 and 2 and 3. These turn into 1, 2, and 3 here. So the number 3 oxygen kind of flips down in that orientation, and the bond has to break. So this carbon right here, I'm going to highlight, we have this carbon is attached to 2 oxygens here. This carbon that we start with is attached to 3. So one of those bonds has to break, and it's this bond right here. And what is actually happening, if you notice the charge state, we have a +3 charge right here. So this bond is going to break, and those electrons are going to flow towards that positive charge. And that's how we break this bond, and that's how that oxygen then becomes a neutral oxygen instead of a charged oxygen. So that's step 2. A lot of people miss that. It's just this one arrow breaking that bond and freeing that oxygen out from that ring. A lot of people also had number 14 still wrong after the review. And in order to do this, we need to look at the pKa values for a different functional group. So we have an amine functional group and we have a carboxylic acid functional group. If I look on that table on the first page that I gave you, the pKa for an amine is 38. pKa for a carboxylic acid is 4.8. This is the acid. So this is going to give up the proton. A lot of people gave up the proton here instead of this proton. So what's going to have to happen is we're going to have to release the electrons between here. So if I actually can make this maybe a little more clear, this bond is going to break and these electrons are going to be given to oxygen. The lone pair, this is going to be the base then, and the lone pair is going to attack that proton. And that is the new form that's the new bond that's going to be created. And then we are going to have the new compound is going to look like this. We have the nitrogen attached to our new hydrogen. That's going to be positively charged. And we're also going to be left with our other compound that was on the other side, and it's going to have lost that proton. It's going to have a negative charged oxygen because the electrons in that bond were given to it. So this should have been what the product was, and again, that's based off of the pKa's that are going to dictate which is the stronger acid versus base. So this is the acid, and the pKa determines that this is going to act as the base in this reaction. That's what I wanted to cover for that quiz review.